So I would let you have one more week to study. So final exam, June 18, from 15 to 18, 3 hours. So therefore you can prepare 3 pages of a trading sheet. And final exam covers from beginning to end. So whatever I'm going to cover today will be the subject of final exam. And of course, from the very beginning of this semester, that is linear algebra, and differential equations and vector analysis. That will be the subject of the final. And the last quiz was a bit easy, right? So final would be maybe a little bit more difficult, but about the same level. So last week we have been studying vector analysis. And so we are going to continue to cover that. And that will be useful for you to taking the electromagnetic theory in the second semester. And how many of you are from the physics department? No students from physics? Okay, so one of the most important relationship between the Levi-Civita symbol is the following. So I, J, K, 1, 2, 3, and I, J, K is in counterclockwise then epsilon ijk is plus 1 if it is, of course, I and j and k are all different. And clockwise, and I and j and k are all different, it's minus 1 and 0 otherwise. That's the basic properties of Levi-Civita symbol. So 1, 2, 3 can be either x, y, z, 2. Then I have a it's called Murphy's law. So something is going to happen. So what happens? 기말고사는 처음부터 끝까지. 오늘 배우는 것까지. So final exam covers from the beginning to whatever we are covering today. So that's the reason why I'm going to end the class today. If I have one more week, then we have more things to cover, right? Okay, thank you. 뭐가 잘못된 거야?
그냥 다시 껐습니다.
Oh. Okay, so I'll let you copy the screen. So this Levi-Civita symbol actually has been appeared before when you study determinant, right? So it must be familiar with you. And usually not covered in the typical engineering math class. So, but this is very useful concept to simplify the calculation steps. So it's good to know. very important property for this. If epsilon kij, if you multiply the epsilon kij by epsilon kpq and sum over k, then you have an important relation, delta ip, delta jq minus delta iq, delta jp. So this is actually not very difficult to prove, and it's better to remember. So for example, if we have a car, if you have some car over function f, and then you take the car again, then you can utilize this property very easily. So car f i's component is jk epsilon I jk partial xj partial k. So x1 is x, x2 is y, x3 is z. You can assume that this way. Then again jk pq epsilon I jk partial xj partial xp partial fq, right? So you can just write this symbolically. So perhaps I can just copy this. Oh. What's wrong with this? 와이파이는 잡혔는데, 그지? 응? 오케이. 이걸 껐다 켜야 되나? I have an impression, I have a very bad feeling that somehow this system doesn't like me very much. Oh. 버퍼 같은 거 다 쳐서 그런가?
저희 시스템이세요?
2로 했어? 오. 입력했는데 안 변하네. 와이프 다시 잡아야 되나? 와이파이 처음부터 잡아야 되나 보다. Okay. So maybe I'm going to repeat it again. So epsilon ijk and epsilon k pq and partial xj and partial xp and fq. And these two can be put them together. And if you sum over k, of course epsilon ijk is same as epsilon kij because it's a cyclic commutation. And it can be put into delta ip, delta jq minus delta iq, delta jp. So sum over pq can be, substituted by putting these two together. So it becomes the partial xj, partial and partial xi and fj minus partial xj, partial fi. So it's partial xi, partial sum over j, partial xj, partial fj minus sum over j, partial xj, partial xj, partial fi. And this is nothing but divergence of f. And this is Laplacian. So we can put down as therefore curl over f is gradient of divergence minus f. As a homework, this could be exciting problem for you to calculate. So probably do it at home. Could be also for the final exam problem. And let's consider some physical meaning of curl and divergence, but before doing so, let's review the mean value theorem. In Korean, it's called 중간값 정리. So mean value theorem is you can actually approximate the integral by this formula. And this is going to be very useful in deriving the integral properties of the divergence and the curl. Let's consider some very simple case. Let's consider an xy plane. And some closed loop. Center is x, y, z. And here, this point, x, y, this is delta y, this is delta x. This point is x, y minus delta y over 2, z. This point is x plus delta x over 2, y, z. And this point is x minus delta x over 2, y, z. And 1, 2, 3, 4. And let's call this is a DL1. Delta x times x direction. And this is called delta DL3, delta x minus x. And this direction is called delta L2, DL2, delta y, y. And this is called DL4, delta y minus y. And consider this is a normal direction, see? So f is called fx, x, fy, y, fz, z. Then we are going to consider closed integration, f dr dl, which is along 1 fx dx plus 2 fy dy 3 fx minus dx plus fy minus dy. So 1, 2, 3, 4 is counterclockwise, and the line integration is depending on the direction. So a little bit complicated, right? So maybe you need to make a copy. So let's try 1 plus 3. This is 1, this is 3. This point is, so this is x, y, this is z. This point is x, y minus delta y over 2, z. And this is x, y plus delta y over 2, z. And center is x, y, z. So 1 f dx plus 3 f x minus dx using, this is delta x. So we can use the mean value theorem, right? So it can be simplified f x y minus delta y over 2 z minus fx x y delta y over 2 z delta x, right? And what you can do is you can divide by delta y and multiply it by delta y. It doesn't change anything, right? Then what happens? This becomes minus partial y partial fx, right? This minus delta y over 2 minus delta y plus over 2. And you divide by delta y. It becomes partial derivative, right? By y, but we have minus sign. So we have minus partial y partial fx delta x delta y, and then it can be approximated by minus partial y partial fx ds over delta x delta y. Using mean value theorem again in the opposite direction. You mean this integration over this. This is ds, right? And how about the other one? We have 3, 4. This is x plus delta x over 2 yz. This is x minus delta x over 2 yz. So integration over 3 f y dy, right? Plus, yeah? Stopped again? It's going to continue.
이게 네트워크가 불안정한 것 같습니다.
설마 내 아이패드 있는 건가? Actually, my iPad is 10 years old. So I hope this my iPad is not in deficiency. Something wrong with the university system. So I will go down as slowly as possible. Fy minus dy, and this is Fy x plus delta x over 2 yz minus Fy x minus delta x over 2 yz delta y. And same thing, you can divide by delta x, multiply by delta x, then this becomes partial x, partial Fy, delta x, delta y, which can be written as partial x, partial Fy, ds, right? 또 멈췄나? I think it's lag가 있나 봐. So partial x, partial Fy minus partial y, partial Fx ds. So actually this is something like this. We have, this is C. So normal direction is C. This is ds. So this is something like a gradient curve f times z ds. Over, first let's wait if it repeats itself. 또 멈췄는데. 왜 이러지?
네트워크 이슈인 것 같아가지고.
응?
네트워크 이슈인 것 같아가지고. 근데 이런 거 혹시 어디다 묻니?
와이파이는 되는데.
이게 될 때도 그 쓰시는 게 느리게 나와요. 네트워크가 뭐 안 좋은 것 같은데 이거 혹시 이런 거 어디다 묻니?
화사무실.
갔다 와.
전화해봐. 구경해주면 6490에 2410. 화사무실. 계속 같은 문제인 거지? Let me try it again. 전화를 해봐, 전화. 6490 2310. Why don't you take a break? I think we have to maybe 10 minutes break. I hope that can be fixed by then.
이게 그 교수님 아이패드 이런 거 네트워크가 문제.
B114.
혹시 번호 알려주시겠어요? 제가 전화해볼게요. 네, 알겠습니다. 감사합니다.
뭐래?
2315로. 네, 저그 B114 안도일 교수님 수업 중이신데 그 리러닝 하는데 이게 네트워크 좀 문제가 있는 것 같아가지고 잘 연결 되는데 이게 계속 끊기고 그리고 이게 좀 느리게 렉 걸리고 그러는 것 같아서 연결이 아마 네트워크 문제인 것 같거든요. 네? 네. 예.
프랑스 클라이언트 내가 보내 나중에 내가 한번 이메일 보내려고 하는데 내 나이에 찍게 돼가지고 AI랑 돌려봤어. 네. 안녕하세요. 예. 이게 연결이 좀 계속 안 되고 있어가지고요. 우선은 so I think that we have a connection back. So in general, if we have some kind of general surface, and this is a normal direction, and this is a dl, then we have the following form: f times dl is curl f and ds, and this is called the Stokes theorem. And Stokes theorem is probably the most important theorem that has a huge impact on our civilization. So I think most of you have taken the freshman physics, right? When you're freshman. How many of you have you taken physics, general physics in your freshman? So most of you taken freshman physics, right? Do you remember Faraday's law? Faraday's 법칙? Faraday's law. So Faraday's law actually says the original form of the Faraday law was the following equation. Curl E is minus partial T partial B. This E is electric field. B is magnetic field. So assuming you have the following form of coil. Copper coil. That's what actually Faraday did in 18 something. So Faraday, one day was very boring. So what do you do when you get bored? When you're really boring, you can do integration, right? You're supposed to laugh. So Faraday did the surface integral of this curl times ds. This is ds, and this is normal direction. It's the following: minus round t round b ds. And this is actually dtd b and ds. And this become this line integral, right? E dl. So if we integrate this electric field along this line, we generate some potential Vf. So he found that Vf is and this is magnetic flux. Okay, he found that if you have a closed loop and if you have a change of magnetic flux, it generates voltage. So what Faraday did was you have coil, and then you move the magnet up and down, changing the magnetic flux. Then he found that it generates electricity. So Faraday discovered the way to generate the electric energy from this integration. So modern civilization is based on the electricity, right? Without electricity, I mean, our IT or this kind of civilization doesn't exist. So everything depended on this very simple mathematical formula called Stokes theorem. So Stokes theorem is really important. And in mathematics and physics, but also engineering. That's the one thing. Another interesting property is calculating the flux over the surface. Copy. So this is probably the most important application of mathematics to the real life situation. So Faraday was, everything started because Faraday has nothing to do. So he got bored, so he decided to do some integration for his mathematical practice. And he discovered that actually there is a way that you can generate the electricity just moving the magnetic field, magnet. Another application of vector analysis is the following. Okay, I will let you. Now we have a volume. At the center we have x, y, z. And some flux of field, F. So let's say this is x, y, and z, and this is normal direction. This is x minus x. Say this is 1, this is 6. This point is x minus delta x over 2, y, z. This point has x delta x over 2, y, z. So we are going to do this one, f and ds over 1 plus 1 and ds over 6. So 1 is the normal direction is minus x, right? So this is going to be, you can approximately have x minus delta x over 2, yz plus fx x plus delta x over 2, yz, and say this is delta x, delta z, this is delta y. So we have delta y, delta z. Then you can do the same thing. You divide by delta x and delta x, right? Then it becomes partial x, partial fx, delta x, delta y, delta z is approximately delta full, delta x, delta fx, dv. So, and you can do the other 4 surfaces, right? Let's copy. X. Okay. So okay. Another direction. y, z. So let's say this is 3, 1, 2. This is 4. So this must be like x, y, z plus delta z over 2. This is x, y, z minus delta z over 2. So this integral 2 f n ds 4 f n ds. So n is actually z, right? O minus z. So this is fz xy z plus delta z over 2 minus fz xy z minus delta z over 2. And the surface is delta x, delta y, right? So this is delta x, this is delta y. So you can do the same thing. You divide by delta z, multiply by delta z, then it becomes partial z, partial fz, delta x, delta y, delta z, and can be converted into the volume integration, partial z, partial fz, dv. And you can do the same thing for the other one, right? The other direction. So maybe I can leave this as a homework. Or maybe I'll just do it here. Because this step is very important to understand. So maybe I'll just do it. X, Y, Z. So this is 1, 2. This is 5. And this point is x, y plus delta y over 2z. This point is x, y minus delta y over 2z. So this integral 2f n ds 5 f n ds is minus fy xy minus delta y over z plus y, sorry, fy xy plus delta y over 2z. Now in this case, delta x, delta z, this is delta z, this is delta x. So you divide by delta y, multiply by delta y, becomes partial y, partial fy, delta x, delta y, delta z is equal to volume integration dv. So what happens if we do the whole integration? 1 plus 2 plus 3 plus 4 plus 6, right? So this is actually 1, 2, 3, 4, 5, 6. It's actually very interesting. Partial x, partial fx, partial fy, partial fy, partial z, partial fz, dv, right? And this is what? Divergence of f, right? So we have another mathematical theorem called divergence theorem or Gauss theorem, which is also very important. Therefore, f closed surface integral becomes volume integral with the divergence of f. And we have found that another closed line integral becomes surface integral with a curl. Right? So this is called divergence theorem. Gauss theorem, sometimes called. It's called the Stokes theorem. So these are the most two important theorems that you need to learn from the vector analysis. And if you have a complete understanding of this, then you will be in good shape in second semester when you take the class on electricity and magnetism. 전자기학. So this is a good background for your, electromagnetic theory class in the fall semester. So maybe you can do some example. Okay, I'll let you copy. Assuming you have a sphere with a radius A. So this is your surface. And if f is given by xx plus yy plus cz. And problem is to find this over the surface. N is, of course, in the radial direction. And this integral looks very complicated, right? But one thing you just learned, that is, you can convert this into divergence theorem, right? So this is basically curl f dv. And what is curl f? Divergence f. In this case, divergence f. Okay. Can you calculate divergence f? Fx is x, right? Fy is y. Fz is z. So what is partial x, x? 1. Partial y, y? 1. Partial z, z? 1. So what is 1 plus 1 plus 1? 3, right? So this is basically 3 times dv. And what is the volume of a sphere? 4 pi a cubed divided by 3, right? This is 4 pi over 3 a cubed. So this is basically 4 pi a cubed. So as long as divergence is constant, then you can very easily integrate this, right? Even though the problem looks very complicated, you can do very easily, right? So maybe another example. Let's copy. Maybe same problem. Where do you say sphere? Say fx is x, 2y, z. And define this. What is this? By now, I think you might be able to calculate this by memory. What is divergence f? 0, right? So the answer should be 0. In this case, right? Because divergence f is 0. So I think this is probably the end. I think I covered what I intended for this semester. So maybe it's good to stop here. So if I continue, then you have more material to cover to study, right? And I think vector analysis is still tough for you. So maybe it's better to stop here. What do you think? So final is 18th, 2 weeks from now. So you have plenty of time to study. And you're going to be very busy for 3 hours. So the linear algebra so you need to study determinant, right? Determinant and inverse. Eigenvalues, right? An important problem is spectral theorem. And polar decomposition. Oh. We have a lot of material to cover in this part only. And differential equation. What is most important? The part of the differential equation, logarithmic derivative. And first order. And maybe equidimensional differential equation. ODE. And of course, inhomogeneous case. Yes, ODE. And Laplace transformation. And we have vector. As well. So these are the topics that I covered this semester. And so we'll be busy for 3 hours. And you can check for the previous final exam problems and quiz problems as well. So any questions? Or maybe I will have some Korean time. So 한국말로 물어봐도 돼요. The difficulty level for final will be, I think, somehow medium. Not very difficult, not very easy either. Somewhere in between. And so 3 pages of cheating sheet will be enough. Yes. 기출 올라갈 거예요. 기말고사랑 아마 그 퀴즈 문제들 다 올라갈 거니까 몇 년치 공부하면 아마 충분히 감을 잡을 것 같고. During the class, I gave you homework, right? So those homeworks are, I think, one of the clue for what kind of problems that will be asked for the final exam. And of course, I'm going to post my class on YouTube tonight. So YouTube class will be useful, I hope. 좋아요도 해주면 좋고. And what else? Yes?
공학용 계산기 필요한가요?
공학용 계산기는 필요 없을 듯. 공학용 계산기 필요한 문제는 안 낼 거예요. 근데 저거는 외워야 돼. 사인 30도, 60도, 45도. 코사인 30도, 45도, 60도. So cosine pi over 6, cosine pi over 4, and cosine pi over 3. That value you need to remember. I think that's all. What is cosine pi over 2? 0, right? Sine 3 pi over 2. Minus 1. Very good. So those basic numbers you need to remember. And of course, you need to remember that the sine, cosine, like how to add them together. So those are the best typical. Yes? So, yeah, any question? Yeah.
세 가지 파트가 혹시 비율이 어떻게 정하게 돼요?
2 to 1? I mean, it cannot be exact, okay? So linear algebra maybe 2, and differential equation maybe 2, and vector analysis maybe 1, 1.5. So I think they will be balanced. Balanced well. Yes.
혹시 지침 시트가
3장, 3페이지. Cheating sheet you can prepare 3 pages because 3 hours, 3 pages. Yes.
이번 수업은 이번이 마지막이고
다음 주는 기말고사 전공기간. 오늘 종료할 거예요. 네.
퀴즈 원래 3번 보는 게 교육이었잖아요.
네.
근데 2개만 보면 이제 하나가 30분 들어가요.
그렇겠죠? 접수에 따라서. 그리고 A 플러스는 10%. A는 좀 많이 주는 편이고, B 플러스까지 한 60%. 영어로 수업을 했는데 영어는 알아들을만 했어요? 내가 말이 좀 빨라요? 또 궁금한 거 있으면 물어보세요. 없으면 good luck for the final. Say fingers crossed. 시험 잘 보란 말을 fingers crossed라고 그래요. good luck이란 말을. 네? 서프라이즈 퀴즈 못 봤는데 동결이랑 둘다서 냈대거든. 그냥 다 보게 해요.
아 그때 그때 그거 가다가
예. 시험 봤어요, 안 봤어요?
아, 시험
못 봤대.
근데 그냥
네, 물어보면 돼요. 교수님 메일로. 네, 나왔어요. 여기 따라가서 시험. 우리 진단원 보내는 거지?
시험 때 받았어요.
받았어요?